Every time you scroll through a social media app like Instagram or ask a question to a modern artificial intelligence, you interact with complex technology. But underneath all those different tools, they share a common language. That language is Python. To understand how dominant it has become, look at this chart showing the programming languages used in artificial intelligence and machine learning. Python commands an 85% market share, far outpacing any alternative. Its story starts in the late 1980s, when a programmer in the Netherlands named Guido van Rossum designed a new way to communicate with computers. And while you might associate the language with a snake, he actually named it after the British comedy troupe Monty Python's Flying Circus. He wanted a name that was short, unique, and a little rebellious against the boring corporate naming trends of the time. He built the language with a specific philosophy: prioritize human readability over machine-level complexity. This approach, combined with a massive ecosystem of pre-built tools for everything from web servers to data analysis, has made Python the standard choice for over 10 million active developers. Computers naturally process instructions in binary, a massive wall of ones and zeros. Since humans communicate in English, we need a translator to bridge the gap between our ideas and the machine's hardware. Older programming languages handle this translation by being compiled. You can think of a compiled language like a chef who must read, memorize, and translate an entire recipe book all at once before they can cook a single dish. Python takes a different approach. It is an interpreted language. Imagine a sous chef who reads step 1 of a recipe, executes step 1, and then moves on to read step 2. The computer translates and runs your code one single line at a time. This line-by-line approach has a massive practical benefit. If you make a typo on step 3, the program stops right there and tells you exactly where the problem is. The instructions from step 1 and 2 still happen, rather than the entire program failing at the very end. Because it gives you immediate, line-by-line feedback, you can test ideas quickly, fix mistakes as they happen, and learn at your own pace. When you are ready to write your own instructions, you open a code editor. This is your digital kitchen counter, a clean workspace where you draft your recipe. The most common first step for any new programmer is telling the computer to display a message on the screen. In Python, that command looks exactly like this. The word print is the action word, telling the machine what to perform. The parentheses act as a delivery box for your information. Inside, quotation marks signal the computer, "Don't calculate this, just read it as literal text." Other programming languages require you to group these logic commands together using complex curly brackets and semicolons, which can quickly make the screen look cluttered and intimidating. Python removes all of that. By relying entirely on standard whitespace and indentation to group ideas, the language forces you to write code that is clean and visually organized. It leaves less room for typos and makes finding mistakes much easier. When a typo does happen, like forgetting to close your quotation marks, the computer stops and hands you a syntax error. It is easy to view an error as a personal failure, but it isn't. The computer is not judging you. The interpreter is simply pausing to ask you for clearer handwriting so it can finish its job. Look what happens when we remove quotation marks from a math problem. With quotes, the machine prints the literal text, 5 plus 5. Without quotes, the machine calculates the math and prints the number 10. Now, take a moment to test this yourself. Pause the video and mentally, or on a piece of paper, write 2 lines of code, one to print your first name and another to print your favorite hobby. Distinguishing between literal text and executable math is how you ensure the computer interprets your instructions exactly as you intended. If you used the action word print, opened your parentheses, and wrapped your name and your hobby in quotation marks, your formatting was perfectly correct. By writing those instructions, you've moved beyond just using an app. You've begun directing the computer's behavior yourself. You now know that Python is designed to be highly readable, and its interpreted nature gives you the immediate feedback needed to fix errors and keep moving forward. This simple syntax scales up through the use of libraries, massive collections of pre-written code. These tools let you use that same logic to perform the heavy math required for image recognition and the complex neural networks powering artificial intelligence. Python removes the historical barriers to programming. By keeping the syntax simple and the feedback immediate, it gives anyone with a computer the power to command the digital world.